today we will be finding the capacitor of a capacitance of a spherical capacitor. Okay, spherical capacitor. Right. We'll be seeing different cases. Okay. Now say, let's say this is a spherical. Just a second. The spherical capacitor. Okay. Uh, the inner radius of this sphere is R1. This radius is R2. Right. We have given it a charge Q plus Q. Okay. Means the outer surface of the inner sphere will be having charge Q. Then the charge equal and opposite charge will also be there. Okay. Opposite facing surface. Okay. There will be a charge minus Q. Okay. On the inner surface of the outer sphere. Okay. Now, if you see that when small r is less than r1, means inside this smaller sphere, okay, electric field will be 0. Why 0? Because if you draw a Gaussian surface, there will not be any charge enclosed, so Q net will be 0. That is why electric field also be 0. And if r is greater than r2, means at this point, if you draw a Gaussian surface, okay, then you will get net charge 0. And if net charge is 0, then electric field will also be 0. Right. Now, this spherical capacitor, in this spherical capacitor, we will be taking different cases. Okay. The first case is this one is that our outer sphere is earthed, means this sphere is grounded. Okay. Right. The outer sphere. Okay. Then for this case, we will be finding our capacitance. Okay. Now you know that C is equals to Q upon V. Okay. Capacitance of a general conductor. Okay. Now, if you see that potential of the inner sphere, means potential of this sphere, that is the smaller one, it will be what? It will be V1 is equal to 1 upon 4 pi epsilon naught Q upon R1, means due to this own sphere. Okay. And the potential due to the outer sphere is also superimposed on it. Okay. Plus 1 by 4 pi epsilon naught minus Q upon R2. Right. So from here you will get 1 upon 4 pi epsilon naught. We will also take Q as common, 1 by R1 minus 1 by R2. Right. This is a V1. Okay. Now V2 will be potential of outer sphere. It will be due to the own, that is due to the outer sphere. Okay. The potential will be 4 pi epsilon Q upon R2 plus the potential due to the inner one. Okay. Will be plus 1 upon 4 pi epsilon naught minus Q upon R2. This will get cancel out. V2 will come out to be 0. Right. So the net potential difference, it will be delta V is equals to V is equals to V1 minus V2. Actually the V2 is 0. So the value of V1 will be what? It will be the net potential difference. Q upon 4 pi epsilon naught 1 by R1 minus 1 by R2. If you take LCM, then it will be R2 minus R1 upon R1 R2. Right. Now you know that C is equals to Q upon V. If you put the value of V here, you will get I think Q and Q will get cancelled out. You will get 4 pi epsilon naught R1 R2 upon R2 minus R1. This is a capacitance. Okay. Now, if the medium between this medium is actually filled with some material having dielectric constant K, then this will be multiplied. Okay. You just need to multiply this by K. Okay. This is the first case. Okay. And one more special case. If R2 is very much greater than R1, Okay, then what? Then R2 minus R1 will approximately be R2, right? So then C will be 4 pi epsilon naught. If you put the value of R2 minus R1 as R2, then they will get cancelled out. It will be 4 pi epsilon naught R1, which we have derived in our first or second video, I think, that due to the isolated capacitor. Okay, and I have also told you one note that you can assume any conductor as a spherical capacitor, as a capacitor whose the other plate is kept at infinite. Okay, now this has been done. Now second case, case number 2, when inner sphere is grounded. Okay, right. When is inner sphere is grounded, so the potential on inner spheres must be zero, right? So potential on inner sphere must be zero. By that logic, we'll get C. I'm directly writing the result. Okay, you will not need to derive it. Okay, C will be 4 pi epsilon naught R2 square upon R2 minus R1. This will be the sorry. This will be the result for outer when inner sphere is grounded, right? You can also derive it. Okay. Now the third case, when inner and outer sphere are connected. Okay, right, by means of conductive wire. Okay, then what will be the capacitance? Okay, it will be actually C is equals to 4 pi epsilon naught R2, right? Here R2 is what? Radius of outer sphere, right? The third one, uh, in this scenario, okay, sorry, the case number 4, it will be something like this. This is a capacitor C1 of radius R2 is connected to the capacitor of radius R1. The C will be C1 plus C2. That means 4 pi epsilon naught R2 plus 4 pi epsilon naught R1. That means 4 pi epsilon naught R1 plus R2. Right. So these were the basic cases of spherical capacitor. Okay. When outer sphere is grounded and inner one is grounded. You can do it by this logic. Okay. You can also find out an inner sphere is grounded. Okay. And when both are connected by means of conducting wire and for this. Okay. So that's all. Thank you.